Hey guys, Mr. Backwork here. In this video we're going to look at solving linear equations with one variable. When we're talking about a linear equation, we're talking about an equation in the form ax plus b equals 0. One thing that we need to be careful of in here is that we need to make sure that that a value is not equal to 0. We do need to have that x in there. And one other thing I want you to pay attention to, that x is a first powered x. There's not an exponent written on there, which implies that it's to the first power. We'll deal with higher powers of x later on, but for now we're just talking about a linear first powered x. As we're dealing with these linear equations right now, our goal is going to be to solve our equation for our variable. So we're going to look at a few operations that will result in equivalent equations for us. And the first one is just simplifying, which includes things like combining like terms, reducing fractions, using the distributive property, that type of stuff. So let's say we had the equation 2x plus x equals 3/9. There's actually two rounds of simplifying that can happen here. On the left-hand side, we've got like terms. We've got 2x plus x. We can combine those to get 3x. On the right-hand side, we've got a fraction that we can reduce down. We've got 3/9, and each one of those numbers is divisible by 3. So we can divide that 3 out of there to get 1/3. Okay, so that's simplifying. Another operation that we can do to get an equivalent equation is using addition. So if we had something like x minus 3 equals 7. Like I said, our goal is to try to get this x all by itself. And right now we've got this minus 3 in here. Well, to cancel out a minus 3, we can add 3. But whatever we do to one side of the equation, we also have to do to the other side. So since I'm adding 3 on the left-hand side, I also have to add 3 on the right-hand side. On the left-hand side, the negative 3 and the positive 3 will cancel each other out, so we just get x on the left-hand side. And then on the right-hand side, we'll have to take the 7 plus 3 to get 10. Similar to using addition, we could also use subtraction. So if we had something like x plus 7 equals 13, to get rid of the plus 7, we're going to have to subtract 7. And again, whatever you do to one side, you have to do to the other side. So on the left-hand side, the positive 7 and the negative 7 cancel each other out. So we get x equals, and then on the right-hand side, if we take 13 minus 7, we get 6. Multiplication is another operation that will result in equivalent equations. So let's say we had x over 3 equals 5. This fraction, x over 3, really means divided by 3. So in order to get rid of divided by 3, the opposite of that is multiplying by 3. And again, whatever you do to one side, you have to do to the other side. So we have to multiply the right-hand side by 3 as well. On the left-hand side, the times 3 and divided by 3 cancel out, so we get x equals. And on the right-hand side, 5 times 3 is 15. The last operation that we've got is division. So if we had something like 3x equals 12. There's no operation written between the 3 and the x which implies multiplication. In order to get rid of the times 3, we are going to have to divide by 3. And whatever we do to one side, we also have to do to the other side. On the left-hand side, those 3's cancel each other out, so we get x equals. And on the right-hand side, 12 divided by 3 is 4. So taking a look at this example, we are going to solve this linear equation. We've got 5x plus 2 equals 2 times 2x minus 3. We're going to start with simplifying, and I'm looking at the right-hand side. We've got a set of parentheses in here that we're going to get rid of by using the distributive property. So we're going to take this 2 and distribute it in. If we take 2 times 2x, that's 4x, and 2 times negative 3 is negative 6. We haven't done anything on the left-hand side, so that's just going to stay as is for right now. Now our goal is to get all of our x's on one side and all of our variables on the other side. So I'm going to take this 4x and subtract it from the right-hand side over to the left-hand side so that we get all of our x's on one side. Now on the right-hand side, those 4x's will cancel out. Left-hand side, 5x minus 4x is just x. We still have the plus 2 equals negative 6. In order to get rid of the plus 2, we're going to have to subtract 2 from both sides of our equation. So we're going to get x equals negative 8. Now what we should do with this is take it and go back up to our original equation and plug it in to make sure that it actually works. We're confirming our solution here. So we're going to take that negative 8 and plug it in for our x's just to make sure that it does work. So we've got 5 times the negative 8 plus 2 equals 2 times the negative 8 minus 3. Now on the left-hand side, I'm going to simplify that down first. So 5 times negative 8 is negative 40 plus 2, and negative 40 plus 2 is negative 38. Now hopefully if we got our answer right, then we should get negative 38 on the right-hand side as well. First thing I'm going to do is take care of the multiplication inside of this set of parentheses. So 2 times negative 8 is negative 16, and then we've got the minus 3 in there. I'm going to take the negative 16 minus 3 to get negative 19, and then 2 times negative 19 is negative 38. So because we got the same answer, this confirms that negative 8 is our solution. Taking a look at this example, we're going to solve another linear equation, but this time we've got some fractions in there. So on the left-hand side, we've got 5y minus 2 all over 8 equals 2 plus y over 4. When we're dealing with multiple fractions within our equation, what we want to do is find the lowest or least common denominator between them. So we've got 8 on the bottom of this first fraction and 4 on the bottom of our other fraction. So here the lowest common denominator is going to be 8. And what we're going to do with that is we're going to multiply both sides of our equation by that lowest common denominator so that we can cancel out all the fractions. So on the left-hand side, we're going to multiply by 8. And on the right-hand side, we're also going to multiply by 8. But we have to be careful to make sure that we multiply the entire right-hand side by 8. So I'm going to throw that set of parentheses in there to show that we're multiplying both of those pieces by the 8. And on the left-hand side, we can just cancel out the times 8 and the divided by 8. So we get 5y minus 2. On the right-hand side, we're going to have to distribute this 8. So 8 times 2 is 16. We're going to be a little careful when we multiply this fraction. 8 as a fraction is 8 over 1, and when you multiply fractions, you multiply the top pieces together, so 8 times y is going to be 8y, and then you multiply the bottom pieces together, 1 times 4 is 4. Now there is a little reducing that we can do with this fraction. 8 divided by 4 leaves us with 2y. So now we've got the equation 5y minus 2 equals 16 plus 2y. Now we want to get all of our variables on one side and all of our numbers on the other side. So I'm going to subtract the 2y from the right-hand side over to the left-hand side. I'm also going to get rid of this minus 2 right away by adding 2 to both sides of my equation. So that's going to leave us with, if we take 5y minus 2y, that's 3y. And then if we take the 16 plus 2, we're going to get 18. So now we need to get rid of the 3 that's in front of the y. To get rid of multiplication, we use division. So we're going to divide each side by 3. And when we do that, we're going to get y equals 6 as our answer. Now, just like we did on the previous problem, we should take that 6 and plug it in on both sides of our equation. So taking our 6 and plugging it in real quick, 5 times 6 minus 2 all over 8 is supposed to equal 2 plus 6 over 4. On the left-hand side, 5 times 6 is 30, and 30 minus 2 is 28 over 8, and 28 divided by 8 is 3.5. Now on the right-hand side, 6 divided by 4 is 1.5, and 2 plus 1.5 is 3.5. So we get the same answer on each side, which confirms that 6 is indeed our answer. That's going to be it for this video. Thanks for watching.